Hello everybody and welcome back to the Toolbox project. In today's video, we're going to get started making the tongue and groove bottom for the toolbox. Let's get going. So again, this step is going to be primarily focused around the router table. However, we are going to talk a little bit about sizing these tongue and groove bases, which will help you even if you're doing this with hand tools. But it is also worth saying, if this seems a little bit too complicated and over the top for you, you could just go for a simple MDF or plywood base for this box. That way you won't need to account for any expansion and contraction of solid wood. You just make it fit and that's it, nice and simple. So over the years, I've discovered that one of my favorite things about woodworking is if you can't be bothered to do the maths for something, just draw it out full size. This is what's known as a ROD, which stands for Rigid Orthographic Drawing, and it is a full-size drawing of what I intend to do with this tongue and groove base. Because if you don't have drawings, sizing these components to account for like expansion gaps and also the tongues and grooves on each of them can be quite difficult. So it's often easier just to draw it out full size and then measure them as they are on here. So I experimented with various methods of doing this last night and came to the conclusion of this top one, which I'm going to talk you through now. Hello, it's Matt from the future here. After gluing the box together, I just wanted to cut in real quick because there was actually a small error I made when sizing the tongue and groove base for this box, resulting in this. When you separate the slats as far as they can go left and as far as they can go right, you actually get a small gap between them. This gap goes straight into the toolbox and therefore it's not airtight in there. They're still locked in place because there's a tongue on the end of them locking into the end grain. But when sizing the tongue and groove between them, I simply didn't make those tongues long enough. The tongue and grooves are also visible on the end of the slats, which isn't something I planned. I don't actually mind it that much, but it's something worth considering if you're planning on making these bases nice and thick like I've done. So instead I'm going to use this Zebrano toolbox I'm working on to demonstrate how to size the tongue and groove base without causing the same problems I just did. So the first thing we're going to do is measure the distance between the shoulder lines on this component. And this is the long component we're measuring here. So in this case, it is 432. So on the piece of MDF, we're going to draw a line that is 432 millimeters long. And then we're going to divide that line into 4 sections. So it'll be 108, 216, and 324. Okay, so when we look at the bottom of the toolbox, that's pretty much what we're going to see in terms of spacing. But what we haven't accounted for here is the tongue on one side of each of these components, and also the tongue on the outside that goes into the toolbox. So let's add those on now, starting with the outside ones. In the previous episode, I sized the grooves to be 6 millimeters deep. So we're going to add a 6 millimeter line onto that, and also a 6 millimeter line onto here. Now to move on to these ones, and this is where I went wrong on my original one because I originally made these tongues only 5 millimeters long. But as you saw, when these are pushed apart to account for that expansion and contraction, you can actually open up a gap. So what we need to do is, instead of going for 5 millimeters on these, bring them in 10 millimeters, quite a lot more. And when you do this, you only need to offset it one side of the line. So I'm going to go to the right, so 10 millimeters that way. And it's best if you roughly draw the tongues on as well, going up to that line that you've just drawn, just so you've got a nice visual aid of where things are going. So I'm just going to draw the rest on roughly so you can see exactly what I'm going to be colouring in here. And then all you have to do is measure what you've drawn. So the first one we're going to do is measure this first slat. So all of that plus the tongue on either end. So we've got a 6 millimeter one here, then 108 and then 10, which will mean this slat is overall 1, 2, 4. Sorry, I'm writing this upside down. We then move on to this slat. This is going to be slightly different because we haven't got a tongue on the right-hand side as you're looking at it. It's just a groove. So this one will simply be that original measurement, 108, plus the 10 for this, making it 118. This next one is exactly the same as this, so that'll be 118. And then this one on the end is different again to all the rest because we've got 108 as the original measurement, plus 6. So this one's actually going to be 114. It's different to this one because on this one you've got a 10 millimeter tongue on one side and a 6 on the other. This one you've only got a 6 on one side and it's a groove on the other, so we don't need to account for any extra material. So what we've got here is a tight fitting base, but the problem with that is these components are going to expand and contract and we've got no gaps between them to account for that. So what you need to do with each of these measurements is take off 2 millimeters from each of them. So this one is now going to be 102, this one's going to be 116, 116 and 122. Scribble these top ones out so you don't get them confused. And so overall that's going to give us 8 millimeters of play in this, which is more than enough to account for any movement throughout a year. But hopefully now you can see my previous problem with 8 millimeters of movement a 5mm tongue was not going to be enough, hence why it's very important we increase these to 10mm. Now this does of course raise the question, what does this mean for the outside grooves in the toolbox if those were already cut to 6mm? For example, what if all of the panels shifted one way and therefore exposed a gap at the ends? For this, you've got a couple of options. If you've already cut the grooves like I have, you can simply put a little bit of glue on the end of them and lock the outsides in place, and therefore any expansion will be towards the middle of the toolbox and it'll be absolutely fine. If you haven't cut the grooves already, simply make them deeper. Make them 10mm rather than the 6 that I've done here. But overarching all of that, in the previous times I've made this toolbox, I've done 6mm all the way around, done the same amount of spacing, and I've never had a problem with it. Bear in mind that these outside panels are locked in 3 edges as opposed to the middle ones which are only locked into 2 grooves. So you've got a couple of options there. As long as the tongue and grooves fit nice and tight, you should be absolutely fine. And so for that reason, throughout the rest of this video, when you hear me quote that tongue and groove as being 5mm deep, remember it needs to be 10mm deep instead. I'll put a little reminder at the bottom of the screen every time I do mention it to ensure that you don't get the wrong information. Right, let's jump back, shall we? And so that's helped us establish the width of the tongue and groove joints. Obviously there would be 4 of these on the actual box. What we haven't done yet is establish how long they're going to be front to back. And we do that using the same method as the lid. Simply measure the internal dimensions of the short components shoulder to shoulder. So 215mm in this case, plus the depth of the groove on either side, which is 6mm either side. So 215 plus 12 is 227. And then when you're all done, you can check these independently on your drawing, and what you should see is they're about 1mm short either side if you've done everything correctly at this point. Bear in mind that you have to check them independently at the moment, because if you try and put them all next to each other, it's going to be massively overhanging at either end. That's because the tongues aren't nested into the grooves at this point. So just check them all independently against the drawing. Check that you're 1mm short either side, therefore indicating that you have reduced everything to account for expansion and contraction. It looks pretty good, so we can move on to the joinery next. So the first bit of joinery we're going to focus on is going to be the tongue around all 4 edges of the bottom panel, as it were, once it's assembled. This tongue is slightly different to the ones inside the tongue and groove joints themselves, because this tongue is going to be central on the component. The ones around all the external edges will be biased towards the top, or it'll actually be flush with the top, and there'll be a rebate sticking out the bottom. Again, this just means that the base protrudes out the bottom of the box, therefore lifting the sides up, protecting the corners, and giving you just a little bit of extra purchase underneath the box when you're picking it up. So with that external tongue in mind, let's get marking it out. The first thing we're going to want to do is set a marking gauge to the width of the groove. So in this case, I've done a 5mm thick groove. Let's set the gauge to 5mm. And then effectively that setting is going to be scribed around all the edges of these components. So you don't need to do it while they're in situ. Just pick them up and do it one by one. Just be careful not to mark the internal face where the actual tongue and groove joint is going. We're just doing the outside ones at the moment. So pushing from the top. Hopefully you can see what we're left with there. A 5mm thick tongue coming down from the top. The only thing we need to sort out now is how far in that needs to go. And so that of course is going into a 6mm deep groove. So that's what we're going to scribe in next. Now because the top of this component is going to make up part of the tongue that goes around the edge, we don't need to scratch this 6mm thick setting around the top face. All we've got to do is flip it over and do it around the external faces of the underside. So again, avoiding the internal joints, just the outsides. Now looking at the underside, this is what we should be seeing. So 6mm in from the edges, and then that goes down to create a 5mm thick tongue at the end. Okay, before we get setting this up, you may remember in the grooving episode we did previously, I talked a little bit about using a false fence. And in this case, this is where we want to use one, and this is why. When we're cutting the rebates on the end of this piece in order to create the tongue at the top, there is a chance of this dipping into the mouth like that. The reason for this is, unlike the sides that we grooved previously that were supported by this aluminium extrusion up here, These are not. There is nothing above the cutter that's stopping it from doing that. And if it does, bad things are going to happen. So we need some sort of support just above the cutter that's going to be pushing on the material that isn't being rebated. And the way we do that is by using a false fence. A false fence is something that I would say is more common on spindle molders working with much larger cutters, but it's still something we can apply to the router table, and it's something I do quite a lot of the time, not only from a safety perspective, but it also gives you a slightly cleaner cut. This is because the fence is actually supporting the remaining material after the cut has been made. And so as a general concept, this is how it works. You get a piece of plywood or MDF or something like that, and we attach it to the fence behind, whether that's screws if you want to do that, or just clamps or something. And then once we're happy that's fixed, you turn the cutter on and we push this back so the cutter starts cutting through it, and therefore is only exposing an area that is cutting. Everything else is there purely for support. So that way we can run this through while that tongue that's remaining is still riding the plywood that's remaining above the cutter. Now it takes a bit of trial and error to do this, particularly with moving the fence forwards and backwards. But the first thing we want to do is get the height of the cutter sorted. Let's just eyeball it first and bring it up to that line we've got on the end grain. And then I'm going to move this fence to a position where it's only taking off about a couple of millimeters. Bring the fences in nice and close to the cutter, not too close, but you want about 5 millimeters to spare either side to give you some wiggle room. And then finally, we're going to shroud off the cutter using one of these. And remember, at the moment, we're only sorting out the height. Once we've got the height established, that's where we'll start fitting the false fence. So I'm going to be testing this on component number 4. You could also do it on number 1, but we just want to make sure we can test it on one of the long grain edges. This is because even without a false fence, this is going to be adequately supported throughout the cut. We obviously don't want to test it on the end because we haven't got that support from the false fence yet. So we'll confirm that's the outside edge and we'll buzz this through and see how it looks. Then we can just test that fit in the existing groove. So that's just about going in there at the moment. And so this is where the false fence comes in. I've isolated the machine and everything, and we need to get this fitted to the fence. One thing it is worth saying is I've taken off the bearing on this rebate cutter in order to allow me to push this fence back far enough to get the required depth of cut. What you don't want is for the bearing to start hitting the back of the fence, because that's going to resist you pushing it back any further. Of course, another way to do this would be to reduce the thickness of the false fence. Maybe go down to 3 or 4 millimeters or something like that. Alternatively, don't use a rebate cutter at all. You could just go for a larger cutter like this, which doesn't have anything on the top that isn't going to restrict the fence from moving back. Right, so what you're going to want to do first is bring the fence forward so that when you attach the false fence, the cutter isn't going to be contacting it. If it is, then when the cutter starts up, you're obviously going to have problems. So make sure there's plenty of clearance behind and get this fence fitted to your existing one. And make sure to lock your fence down while you do this to ensure you don't get any movement. And if you can, get a featherboard on. There we go, so false fence in position, securely attached. So now we're going to turn on the router, let it get up to full speed, and then push the fence back through it. Of course, take your time with this. If you feel any resistance, don't keep pushing. All right, here we go. Sorted. So now as we push this through, as you can see, it's going to take the cut on that lower section, but the top of the material is going to be supported by that bit above the cutter. All we've got to do now is just work out how far back this fence needs to go in order to give us the desired cut. My recommendation for doing that would be to set it too shallow, so bring the fence forward a little bit, and then we'll just keep testing it until it hits that line on the bottom of the component. And I'd also recommend you have some sort of support behind this when you push the ends through, not only to keep it perpendicular into the fence, but also provide support on that exit cut. So I'm going to get doing a bunch of test cuts until we get to the required depth. So I'll just quickly do the opposite end and then see where we stand with that. And again, we need to check this on the component itself. And so what we're now looking for is for that distance between the bottom of the rebates to be the exact same distance as the bottom of the shoulder lines. If it's anything more than that, you're gonna have to trim it back. If it's bang on, happy days. And if it's a little bit less, don't worry too much about it. Hopefully you can see that's what we're looking for. So on either end, exactly the same length. Just the shoulder lines. So that's going to be a really nice fit at the moment because it is exactly the same length as the shoulder lines, but I'm just worrying a little bit that if I make it that perfect, if there is some sort of little bump or there's a slight angle on the end of these for whatever reason, I don't know, that's going to resist the toolbox going together at the end, which there's a lot of components all coming together at once when you glue this up, and so if there was something like that that caught me off guard, that's going to cause a lot of damage. And so I'm probably going to reduce that by a further 0.5 millimeters either side, just to give me that tolerance in case something goes wrong. Again, we can sort of disguise that slight gap by using a chamfer and things like that. But for a project as big as this, it's probably not worth the risk. That's probably hard to see it, but there is barely anything on the end of that now, just poking out beyond the end of the rebate, giving me a little bit of tolerance when I put this together. So with that rebate established, we're going to continue doing both ends of all of the components, and then we'll take the two outer ones, 1 and 4, and just do those two external edges on them afterwards. Once again, emphasis on doing the end grain first. That way, if we get any breakout, we'll remove it when we do this long edge, or you'll remove it when you do the tongue and groove. Right, so quick sanity check. Let's get them all laid out again. Check we put them all in the right places. So what we should be seeing, the correct way up, is a rebate around all the bottom corners of all 4 components, which we have got. So let's focus on the tongue and groove joints next. I'm working with a 15mm thick piece of material here, so it makes sense to carry on using my 5mm slotting cutter to put a 5mm slot down the middle of this. Saying that, it doesn't actually matter if the groove is a third of the thickness of the component. You can make it 6, 8, 7, whatever. I'm going to show you a very simple method to ensure that that groove is perfectly central, and also size the tongue on the opposite component to fit it perfectly. So it's probably worth highlighting at this point that we're obviously going to need 2 different cutters to do the male and female parts of this joint. As for the tongue, the male part, we're going to be using the rebate cutter. For the groove, as we've already discussed, we're going to be using the slotting cutter. Now, even though the rebate cutter is already set up in the router table, don't be tempted to do the male parts of the joint first. It's actually far more easier and more accurate to cut the groove first and then make the tongue fit that groove rather than the other way around. Of course, there's an expense of time in that, but it'll be worth it. So we'll, of course, isolate it first and then start breaking this down. So before we even start thinking about cutting anything, let's quickly mark out which components are due to receive grooves and which faces are due to receive grooves as well. It doesn't actually matter if you do it on the right or the left-hand side of the components, as long as it's the same on each of them. So I'm going to do it on the right-hand side as you're looking at it, and I'm just going to put a big dark line down the center of each of them. Okay, so it's just going to be on those 3. Obviously there's no need to put one on here because that's being joined into the box, and we'll leave it like that for now. We won't do the tongues on the other side, just leave them blank. That way, when we're at the router table, we've just got one face that has a dark line on it. We know that's the one that we need to do. Next, on one of those faces, get your marking gauge and just eyeball it to halfway. When you think you're there, give yourself a mark. Flip it around from the other side, give yourself another mark. And so what we're looking to do here is establish a center point on this component, and marking from both sides makes this easier. So we can see we've got 2 marks there. You want to reset the gauge to go halfway between both of them. Again, pick a new point of the component, give yourself a mark from that face, give yourself a mark from the other one, and if they line up, you know you're bang in the center, which is what we got there. Once you've got that center mark, take it to the router table, and again, just eyeball the height so that the line is halfway along the cutter. Once you're happy with the height, we'll do the old tape trick again to get the depth of cut in the width. So get it so the cutter is positioned with the blade at its furthest point out. Bring the fence forward to it, lock that down. Get a bit of tape to mark the 0 points. And then we'll push that back to 6mm. Get the fences in nice and close again. And then finally the featherboard from the top. Okay, so obviously so far the methods we've used to centralize this cutter on the thickness of the piece have been somewhat rudimentary. The marking gauge was set up as close as possible. The cutter was eyeballed to that center. How can we be absolutely certain that this cutter is cutting directly in the middle of this component? Well, the simple answer to that is you run it through one way, like that, and then you flip it over end to end and run it through the exact same but the other way around. That will then cancel out any slight misalignment, and it will give you a perfectly centered groove. It might not be 5mm thick, but hey, we're going to size the tongue to fit it later anyway, so who cares? And when you're doing operations like this, make sure to only bring the components that you're actually going to be working on over to the router table. Don't bring the other ones over, because in this case, it's just these 3 that are going to be getting grooves. All right, let's do it. Okay, so that's the grooves established. We're next going to get the marking gauge again, and we're going to use this to lay out the tails. So pick any one of those grooves that you've just done. We're going to set the marking gauge from one face to the start of the groove. So just like that. And with that setting, you're going to use that to lay out the tongue on the side that is adjacent to the one with the groove. So groove on that one. Obviously, we're going to do the tongue on this one. And you're going to scratch that up from the top and also the bottom as well, therefore giving you a perfectly centralized tongue. Hopefully you can see now why we did the groove first. And of course, this is only going to be marked on 3 components again. This outside one has already got a tongue on it. And just to make it clearer when I'm on the router table, I'm also going to mark the waist. Okay, so we'll bring that cutter up to the height of the bottom of the tongue. Maybe let's do it a little bit lower to start with, and then we can slowly creep up to the final height to give us a nice fit. Yeah, perhaps about 0.5 millimeter below or something first. And seeing as we need to do a test cut on this first, let's get it so it's just nibbling off a couple of millimeters to begin with. Doesn't quite fit at the moment, so we just need to bring that cutter up a little bit more to make this a bit thinner. Not quite as snug as I would have liked. It still holds pretty well, even with only a 2 or 3 millimeter long tongue. So let's adjust that fence to cut the entire depth now. Then we're going to do the old masking tape thing again. So get a flat piece of timber, rest that against the cutter, bring the fence out to be flush, double check it, yep, and set it back 6 millimeters. Okay, so weirdly, one of them's ended up, sort of as we discussed earlier, a little bit on the loose side. The others have ended up being too tight though. They grab, but it just needs a little bit more material taken off. So I'm just going to set up a shoulder plane to take a skim from the sides that need cleaning. So once again, you've got a choice at this point. You could either leave these square-sided, or you could put a little decorative chamfer on them, which is what I'm personally going to do. Similar to the lid, this will add a nice little detail, as well as hide any small discrepancies in the gaps when this stuff expands and contracts with the seasons. And so for the top side, the only ones you need to do are these pairs that make up the internal joints. You don't need to do the outside because that's all hidden within the groove. As for the underside, you can basically do all 4 edges of each component. In fact, it's actually strongly advised you do all 4 edges because, again, when this thing is slid around on workbenches or whatever, those chamfers will help prevent the corners getting caught on anything. So let's start with the other side, count the number of strokes we're doing. For me, it's usually somewhere around 10, and we'll do that on both the top and bottom. And there you go. That's how you make the tongue and groove base for the box. A lot of processes were covered in this video, primarily around the router table. If you take anything from it, remember the concept of using a false fence when doing short ends of components. You do not want that getting sucked into the mouth of the router table while you're trying to put a fine detail on things. Using a false fence is the way forward. And of course, we haven't addressed this yet, but if you're doing it by hand, all of this can be done using a rebate plane, all of which we've covered in previous videos. And as for the grooves, we've covered how to do that by hand in the cabinet series. You may not find it as easy to do that trick I showed you with regards to flipping the piece upside down to get the groove perfectly central. Doing it by hand might require a little bit more of a bespoke fit, but I guess that's the thing you get from using machine tools with this. So, as always, thank you very much for watching. If you enjoyed the video, please do not forget to press the like button, subscribe if you haven't already, and I'll see you in the next lesson.